All right, so our next project is going to be this Series 20 Pioneer F26 FM tuner, and this is probably one of my favorite, if not my favorite, FM stereo tuner of all. And it just so happens that we also have a matching Series 20 preamp, and this is the model C21, and it is your total minimalist preamp. It has right and left gain, one tape loop, a volume control, two cartridge loading controls, and your input, which basically is just phono, auxiliary 1 and auxiliary 2, and your tape loop. That's it, nothing else. So this is for hardcore phonos people that want the absolute most direct, pure audio path that you can possibly have. And so it's kind of interesting. So I just thought I'd show this. We're gonna do a checkout on it after we check this one out, but this is gonna be the project for this video. So if that sounds interesting to you, stay tuned. Before we hook this up and test it out, I just want you to take a look at this thing. I mean, the gold input terminals, the controls on the back, the sensor gain, the de-emphasis, of course, you can change for the different regions that you're in. Just everything. It has its own ground, like a separate ground, even with the banana plug input. This is just, to me, the highest quality you can possibly get. It is really impressive, and this is a great little receiver, a little tuner. So I'm going to leave everything at midpoint. I'm going to go ahead and connect this. I'm actually going to take this off of here. We're just going to connect it directly into the 75 ohm. We'll see how it works. Don't know. Sometimes it's better to hook it up with the Ballon and the 300 ohm. Sometimes it works better this way. Just depends on the tuner. We'll see how this one works. I think this one will work well no matter what you do to it, because it's an F26. Yes, I am rather partial to these things. And like I said, they're unicorns. I never thought I would ever see another one again after that one I had on the bench several years ago. But lo and behold, Dave came up with, well, pulled another one off for us. So I'm going to hook up the multipath also so we can just look at it. I think that would be fun to look at, don't you? And let's see here. Hold on a second. So in order to view the multipath on an oscilloscope, you have to have, your scope has to be able to be capable of XY mode, so it needs to be a dual channel scope, and you're going to connect it to the vertical and horizontal output of the multipath, and then run it over to your scope. I'll show you that in a minute. Okay, so this is one of the most simple tuners in the world to operate, because it has an on-off switch, a muting switch, and a tuning knob, and that's it. Don't let it deceive you, though. There's a lot going on inside this thing. So in order to operate this, you're going to go into XY mode on your scope, however you do that for yours, and you're going to use the two channels for the vertical and horizontal. And it's not turned on now, so I don't want that dot burning the phosphor on my screen, so I turn it down. And we turn this on, and I can't play music, obviously, because copyright stuff. But you can hear that. White Snake, I guess it is. And you can see it right there. So let me go through here and kind of show you, as we tune through it, what it does. So I'll move this over a little bit. And you can see it you can see how I can bring it right in. Kind of makes a smiley face, and then when I let go, it should lock, but of course, I don't have a very strong signal right now. I mean, it's on there, but there, it locked. Okay. And you can see that. And then you just kind of go through, and this tells you when you're on a station, and it tells you which way to tune it. It's already on stereo. If we go, it says tune, and then it goes to locked and stereo. So, and you can see we have some really good very clear station. Let me tell you, these stations, they sound like they're pretty nearby, but from where I am on a normal tuner, it's nowhere close. It just won't bring it in like that. So here's the same station. Hear how that is? Now I go over to this one, and let me move the antenna over real quick while the song's still playing. Hear how much clearer it is? It's like no comparison. And by the way, that 2240 is a decent tuner, and it's been freshly aligned and everything. It's working as it should. It's just, this is that much better. So we'll take a look inside and kind of go over some of the features. Now, the SA9800 tuner that you've seen me do a couple videos on those, and the Pioneer SX1980, I think, also has the feature where when you touch this, see how that goes out? Let me turn the light off here a little bit. You see how that light goes out when you touch it? That's actually a touch-sensitive tuning knob. And what it's doing is it's removing the phase lock loop on there until you tune it on center of channel. Once you're tuned on center of channel and you release that, it activates the phase lock and then locks the channel in. And that's a really unique feature. You don't see that very often on tuners, but the SA9800 and I think the SX1980 both have that feature, and that was carried on to this. And I think the F28, if I recall correctly, the F28s will also do that as well. Just pretty cool. So you might say, what are we going to do on this video? Well, not a whole lot. What we'll do is we'll kind of take a look at the schematic a little bit. And the bigger thing is, let's look inside, and you can see what a work of art this thing is inside. I'll get it down on the bench, and I'll get the cover off, and you'll see what I'm talking about. So as we're taking this apart, there is also a series of power amplifiers to go along with the S20 series. One is a pure Class A amplifier, and of course it can double as a space heater on those cold days. And the other is a Class AB, which is like 120 watts per channel. And maybe one day we'll see one of those on the bench now. Wink, wink, nod, nod. So here it is. And it is, like I said, this thing's a work of art. And just amazing. It just looks so clean and neat and so forth. So as you can see, there are quite a few capacitors in here. I don't believe any of them are going to be bad, with the exception maybe of some of these orange ones. These low leakage capacitors, low noise caps, they actually do get leaky with age. These other ones, it wouldn't surprise me if every single one of them is good. I think these are those Nippon Chemicons, and they're really good caps. So I may not need to touch them. And there's how many screws holds the bottom cover on, so you better have some sort of a power screwdriver or your fingers are going to be tired, or your wrists. And look at that. And there's your power supply. Again, I mean, you know, no expense was spared on any of this. It's very, very quiet power supply in this thing. And I'll go ahead and check a few things on here, but I have a feeling it's not going to need anything done to it right now. Maybe down the road someday, but not now. But we'll look. Okay, let's check all these real quick. That one's good. 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 And again, we're only testing ESR on these caps. I mean, leakage and shorts and things you're not going to find, but usually, as long as you don't see a short on here, good low ESR is usually a good indicator on these types of electrolytics, if the capacitor is okay or not. Now, you know, there's other things that can go bad, but usually when they go bad, the ESR will start to go up. And that's not always, but sometimes, most of the time. So we'll just check a couple of these orange caps here if I can get on them from up here. I don't know if I can get at them from the top. This one here is just too tight on the board. They all are really. I can't get on them. Yeah, I can't get those. They have them just so tight to the board that you can't get them. So, oh well. There's one. Let's see. There we go. And again, when you're looking at something that's only, this one's a 0.47 microfarad electrolytic, or what is it? 0.22. So you can see this is a 0.22 electrolytic. And of course, 0.22 in a film would kind of be a little bit big, even back in the day when these were on there, but they did use film caps on here, and they could have if they wanted to. But again, sometimes they use these electrolytics because of the ESR that they do have when compared to a regular film cap. And that's part of the circuit. It's actually baked into the circuitry. So typically with things like that, you would want to replace them with a like capacitor. But anyhow, these are all pretty much going to be good. I mean, everything's working perfectly on this. And they're built to a little higher standard. So usually the components they used on these were premium, and they lasted a really long time. By the way, before I start this, give me your honest opinion, everybody. Do you like things like show and tell videos like this? Or would you rather just stick with the technical, fix things, whatever, you know, testing and so forth? Let me know down in the comments section, because I have a lot of interesting equipment, not just this sort of stuff, but, you know, I have some stuff that I use for testing X-ray out in the field, you know, different kinds of test equipment. And some of it, you know, doesn't need repaired. It just might be interesting to see. Let me know your thoughts down there in the comments. Anyway, as you can see, I took the cover off here of the tuning gang, and it is a 7-gang tuner, and it's all 7 gangs are used for the FM. A lot of times you'll hear a tuner, they'll advertise it as a 7-gang tuner, but really it's only 4 gang for the FM and then 3 gangs for the AM or something like that. This one is an FM only tuner. So it has quite a few stages, tuning stages to it, and it's a linear gang tuning, which is a little bit different than some of the others. It has some really interesting features. The schematic is relatively complicated, I have to admit. And you can see on the front end, this is where your tuning gangs are. And you have a capacitive coupled stage right here, RF stage. Then you have another RF amplifier. And then you have a magnetically coupled stage. So the capacitor coupled, this gives you the real sharp tuning. And then this one has a wide bandwidth to it. And it's kind of how they do this. So it's double tuned. There's a double tuned capacitor coupled, double tuned magnetic coupled. And then when it comes out of there, it goes all the way around here. You have this APC control, and that has to do with your phase lock, the touch sensitive. You can see there's the tuning knob, and this is the touch sensor and all that for the phase locking. It comes down here, and this is your IF strip. And if we go over here, here's all those little dual gate MOSFETs, or JFETs, I should say, dual gate, and your tuning gang. So your RF comes out of here and it goes up into here, and this is your tuner board, and this is all the IF stages. And look at all of these op amps, or these amplifiers that they use to amplify the different, each stage. And you can see the little ceramic filters. So there's a combination of ceramic filters and of course your transformers. And then at the very end, you have this surface acoustic wave filter or SAW filter that I'm getting off camera here, huh? This SAW filter right here. And if you look on the schematic, so here's all of your stages of IF amplification. And you have the little filter in each one, and then there you go into that SAW filter, and then one final amplifier. Then it goes through this section here and into this detector, which is really cool. This is down here. And this is called a pulse count detector. It's really interesting, and I have a little sheet here that kind of demonstrates how a pulse count detector works. Now, most analog tuners that you see, the earliest ones had what was called a discriminator or a Foster-Seeley discriminator circuit. And then later on they went to what was called a ratio detector, which is kind of a modified, it's like an upgraded version of the discriminator. And then after the ratio detector came the quadrature detector. And then this thing came out. And this is really interesting. And none of these things are really digital as per se. It's still analog circuitry, but it's really cool how this all works. So if you have your original FM signal, so think of this as your carrier, this first line up here. And you notice how you have the frequency variation because it's frequency modulated. So this is showing the carrier, and then this is showing the modulation of the audio on the carrier. That's what frequency modulation is. So what they do is they amplify it and send it through a limiter circuit, and when it comes out, it looks kind of like a wonky looking square wave. See that? So now you have these square waves with a very accurate amplitude to them. And then they have a zero crossing detector. So you see you still have the frequency, and you still have the modulation, on the frequency. So your carrier and your modulation. But all they're doing is they're just looking each time you have a zero crossing. So when you go from the positive to the negative, and there's your zero line, whenever you see that zero crossing, it puts out a little pulse. And you can see the pulses now only have will have the information once again of your carrier frequency and of your frequency modulation. See that? So lower frequency, higher frequency, frequency modulation. And that goes in to a monostable multi-circuit. You can see that. And all that is, if you look at it, is a pulse width modulated square wave. And then after that, they run it through a low-pass filter, and from the low-pass filter, you get your audio. I'm going to stop for a second and ask you a question. Does this remind you of something? Just kind of this section right here, does that remind you of anything? If any of you said a Class D amplifier, the ones that are so popular today that we buy on eBay and Amazon and we buy on AliExpress, these little amps are this big and 2 billion watts per channel, and they run on a wall wart. I don't know how they do that. I guess they don't have to follow the law of conservation of energy. But anyway, yeah, this is similar to a Class D amplifier because really that's all they're doing is they're setting up a pulse train of square waves, and then they're pulse width modulating it, and then they're running it through a low pass filter and getting your audio. How about that? We've been doing this for a long time, huh? So anyway, all of the high-end tuners, or many of them from this time, used this technique to detect the FM instead of using like a quadrature or a ratio detector. And one of the things is this is absolute minimum distortion you could possibly have, because really it doesn't care about anything you know, on that waveform. It just cares about the frequency modulation and the actual carrier frequency itself. It kind of strips all that other stuff away. So it's very accurate. So as a result, that's how this works. I just thought that'd be interesting to look at that. So that takes place here, and then it goes down underneath, and there's a actual multiplex circuit, which is right here. And this is what takes any of the information that's, let's say it's a stereo signal. Any of the stereo modulation will get stripped off here from this circuit and then be turned into your stereo output. And then this thing has a pretty good audio output section as well. Let me see if I can find that on here. Right there's your audio. But you can see, once again, there's your left and right channel, and it's just uses an integrated circuit for your audio output. And there's your variable, and there's your fixed. And again, very clean audio output. So it's really cool. And there's a lot going on in this thing again. And they're showing the APC circuit over here, if you're interested in what it looks like. But it's very complex. And the layout is great. And look how tiny this whole thing is. You know, that's what amazes me the most about this, is how small this whole thing is. Now, as I said, this was a pretty rare tuner. It was only made for 2 years. I think 1970, the middle of 77 to the middle of 79. So just, that's it. So you only have about a 2-year run of production on this. And apparently there is a TX 9900. Now I have a 9800, as I said. I've had a couple of them. And they're excellent tuners, but they're not quite like this one. They do share some of the features of these, but this is way more refined and advanced. The 9900 was kind of almost this tuner, but it was a lot bigger. It was about the size of a 9800, and then they came out with this one. It's pretty cool. And then, of course, we won't talk about the F28. I'll leave that one to you. Go back and watch my video on it if you want to see it. I'm still receiving therapy for that whole experience. No, that was a really fun project. I liked it. Now, just to give you a few ideas, 2 of these 3 tuners here, this is a comparison chart of all the specs of the top 3 analog tuners ever made, at least what a lot of people consider to be. And it's really interesting. I had a TUX1. I've had 2 of them, and they're spectacular. And the AM on these is just awesome. And the FM is pretty close to this one. There really can't tell much difference. The only thing is it's a beast. It's a huge tuner, not a little tiny thing like this. But in its own right, it's a fantastic tuner. And I've never had, nor have I ever seen, a Kenwood L02T in person, but it is supposed to be the pinnacle of all the analog tuners from what I hear. There's some other ones out there, you know, Macintosh and Rance and things like that, but, you know, we had the 10B and some things like that, but really, this is kind of, a lot of people agree this may be the best of all of them. But I'll let you read through this. If you want to just kind of pause the video, and you can go ahead and kind of read the specs and how they all compare to one another. And it goes on for 3 pages here. And I'll let you, again, you can just pause the video at any time and just look at all these specs. This is interesting stuff. Again, some of you may not be interested in this, but I really am. And again, I know a lot of you get down on FM tuning, FM analog broadcast, because really FM broadcast is kind of in a decline a little bit compared to how it was in its golden era, you know, in the 70s and the 80s. A lot of the stations today that are still in existence, don't use the same kind of broadcast equipment that they used in those days. So the quality of the broadcast isn't what it used to be, quality of the programming. So I get that. But I don't really do this. I don't listen to a whole lot of FM. Sometimes I do, but I'm just fascinated with this. How they took, today you take it for granted. Everything's on a chip. You buy this chip, digital signal processing, and SDR, software defined receivers and things, and they just work. They're amazing. They're right out of the box, cheap, throwaway parts, and they work great. And there's just something about this technology that really impresses me. Now, if you want to look at the block diagram, there it is. And thankfully, we don't have to do this. We're going to do a couple tests and then we're going to wrap this video up. But this is for just an FM stereo tuner, look at the amount of alignment there is to this thing. So there's page 1 of the alignment, page 2 of the alignment, page 3 of the alignment. The IF circuit has no less than 45. It might be continued on the next page. Oh, I'm sorry. 50, yes, count them, 50 different steps to doing the alignment of the IF alone. And then here's your stereo demodulator for the multiplex. It's very involved, and you really have to know what you're doing on one of these. If any of you came along for the ride with me on the F28 and on the TX 9800 and on the TU X1 and on the Pioneer SX 1980, all those tuners, they were really, really complex alignments. And you can see from my videos that they were difficult. And this is no exception. So don't let the small size and the simple, only a couple of controls fool you. The fact that it doesn't have a lot of controls on it makes it even more complicated than the ones that do. So pretty cool. So I'm going to get the cover back on this thing and put it together, and we'll just do a couple of tests just to see how it performs. Okay, under optimal conditions, so having like a 500 microvolt signal, not including the losses and everything in the cabling and the mismatches and things, but it's pretty close. It's saying in here in the specs, with a stereo demodulated signal, you should have about 0.05% THD at 1 kilohertz. And I have 1 kilohertz signal. You can see it. It's pretty clear on a scope. And looking at the distortion meter, kind of floats around there. Somewhere between, it's right around that 5. It kind of jumps around a little bit. Remember, my test equipment can't really, this is really taxing the limits of my test equipment. I'm using the Sencor SG80, and it's just, the internal modulation on that you're really pushing it. But it's doing it. Now, if we go to, let me lock this in here. It says at 6 kilohertz, it should only jump up to 0.07%. So I don't have a 6 kilohertz, but I do have a 5 kilohertz. And not too bad. It's 0.09, which is still very respectable for an FM tuner, especially when you're demodulating it and everything. And I have the pre-emphasis and everything turned on. So not that that really matters right now, but, and then there's 400 hertz. And again, even that's not bad at the lower frequencies. So pretty good. Okay, now the next thing is how low can you go? I'm going to leave the I'm going to go to mono right now. And I'm going to turn this on. You can hear it. And what I'm going to do is I'm going to slowly reduce the signal strength of the FM carrier until we get a pretty much, you can't tell it's a sine wave anymore. So let's go way down. So I'm at the very lowest at the ×1. Let me see if I can get this all in shot here at the same time. Just barely. Yeah, there we go. Okay. And right now I'm at reading ×1. So I'm at about 0.5 microvolts. And look at the signal. You can still, if we listen to it, just a little bit of signal. And again, this is a mono signal, so you can get way down in the dirt with that. Okay. Let's see if it'll do. And even at 0.3 of a microvolt, you can actually hear the tone over the static. So for an FM tuner, that is really good. And if I go to stereo, of course it's not gonna pick up the pilot on that. Turn this up a little bit. So there, I increased the modulation a little bit, and with about 80% modulation at 0.3 microvolts, doesn't sound too bad, does it? And if I go to stereo, it still doesn't go in, it doesn't pick up the pilot, but if we go up a little bit, let's see. I'm looking at the stereo indicator on the tuner to see when it pops in. Not yet. There it goes. Okay, so let's go down till it drops out. So it drops out there, it comes in here. So right around 100 microvolts, you get stereo on this tuner. So it needs about, looks like it needs about 100 microvolts for a good stereo signal, at least on my test equipment. All right, so let's play some music through it and kind of listen to how it sounds. So you can see my desktop computer is feeding into the buffer preamp. It's coming out of that. It's going into the external inputs of the SG80, and I've tuned it in, giving it a fairly decent signal to kind of see what a strong signal would sound like. And let's play some music. Show you that I was actually tuning it in. Now watch how I tune it. Take the green light. There we go. Let go. It locks. Okay, you get the point. And let's just do a frequency sweep and see just how wide of a bandwidth this can do. Now, I don't have IF wide lit up yet, so I'll probably have to get a little bit stronger signal to do that. And I just realized I'm talking with my microphone sitting on the bench aimed at the speakers. Okay, so let's see if we can get IF wide to kick in. And I think to do that, you have to have a little bit stronger signal. Nope. It is not kicking in. Okay, so I see a little bit of an issue here. When it locks on the wide band, I don't get quartz lock. And I don't know if that's normal with this or not. I mean, it is definitely a different sound. And if I go a little bit on to tune, it drops off. I got to go ever so slightly to the right of center tuning. So it tells me the alignment is out a little bit. So I may have to touch that up at some point in time, which I'm not going to do today. But I just want to see what kind of a frequency sweep I can get out of this. So that's going to probably have something to do with the IF alignment. And because this is a pulse count detector, it doesn't work the same as you would with a ratio detector. The alignment is different. There's not much to align in that, so it's probably back in the IF section somewhere. And you see that's the one that had 50 steps, and I'm not going to do that right now. But let's just see. I mean, other than it being not going into quartz lock, it's still on center frequency right now. We just have to kind of tune it a little bit, and it's so slightly off. It's just so close. But what I'm going to do is I have the function generator feeding the input of the SG80 so that I can make different frequencies, and we're going to just see how low and how high of a frequency this tuner can resolve, because FM is kind of limited in frequency. A lot of times it'll cut off around 30 or 40 hertz at the low end, and it'll cut off around 15 kilohertz at the high end, if in a perfect world, but not even that far in a lot of cases. So let me cue this up. Okay, let's start with 1 kilohertz, and you can see the tuner is working very well at 1 kilohertz. And the idea is, as I change frequency, I want this amplitude to stay the same. So let's go down to 30 hertz. Should be able to get that. And it does. And you can see the amplitude is perfect at 30 hertz, if this thing will focus. Come on, focus. It's not happy. It's very unhappy. Okay, looking at frequency, there is 25 hertz right there, and it's resolving it very well. Okay, there's 15 kilohertz, and that's at 50% modulation. And let's go up one more and see if we can go to 16 kilohertz. And there's 16, you can see how it drops off. And then by 17, it'll drop way off. And then at 18, it should be gone. It is. And then at 19, and that's your 19 kilohertz trap. So you can get the full bandwidth, full FM bandwidth on this thing. Now just remember, FM broadcast can't go beyond 15 kilohertz. That's the highest frequency it can resolve, because the way FM works. 19 kilohertz is your pilot tone for your multiplex. So it doesn't use 19 kilohertz as an audible signal, so it has to actually filter that out. So anything above about 15, 16 kilohertz, it starts dropping off. And that's how it works. That's just how tuners work. So it's just something we're going to have to live with, right? By the way, Dave found this beautiful case, and I believe somebody made it, although it looks factory and it fits on here perfectly. But doesn't that look awesome? So there you have it. The Pioneer Series 20 F26 FM tuner. And once again, like I said, it definitely, I think we need to do an alignment on the IF to get it perfect, but not something I'm going to do today because I got too many other things I want to get done. Basically, the tuner works. It sounds great. It works good enough for me for right now. But one day we'll come back to this and we'll do the alignment on it. So until next time, I wish you all peace, joy, happiness, and good health in your lives. We'll see you again real soon with the next project. And again, let me know if you like these show and tell kind of videos, and maybe we'll do some more. Take care, everybody. Bye-bye.